Hey students, we are talking about the distributive property, day 2 today. This is, it's kind of just a one more step added to what we've already been talking about. So I just want to kind of show you that it isn't anything that you already don't know how to do. So let's say that we have this distributive property problem here. All right, so yesterday we learned about how to use Santa hat, and it's just the way that we distribute. So we're going to go 2 times x. Now you can see we have 3 terms inside of this parentheses. We have to multiply all of them. So it's not quite a Santa hat, but we're using that same process. So 2 times 2 is 4. And then we have 2 times 4 with x, which is 8x. Now, if you remember last week, we talked about if we have things that have the same last name or belong to the same family, they have to go together. So we can see that that 2x and that 8x go together. So we have 10x, and we have that 4 by itself. So there we are. That right there is our answer. This distributed and became this. So that is kind of what we're going to be going over today. So let's move on to your bell work. All right, so we're looking at number 1 here. Number 1 says Miss Smith has 28 6th graders and 35 7th graders for math. If she wants to break the 2 grades into identical groups without any students left over, how many students will be in each group? All right, so we're talking about grouping here, and we're looking for, let's identify some words in here that might give us some clues. So we're breaking the groups into identical groups, no leftovers. How many that makes me think about greatest common factor. So I wonder if we did this. 35, 28. Well, what number goes into 35 and 28 evenly? 7. Oh, so that would be 5 and this would be 4. So my greatest common factor is 7. So wait a second. If I had those 6th graders and I broke them into 7 groups of 7, I would have 4 groups of 7. And if I did the 35, I would have 5 groups of 7. So groups of 7 is what I'm looking for. How many students will be in each group? 7. Oh, that wasn't too bad. Okay, so now number 2, we're finding the area of each of these figures. Now, if you want to find the area, this is the formula that you're going to want to use. In 5th grade, we did area equals length times width. And I want you to think about this. We're going to start using this term, base times height. Because you're going to see later on why this terminology, I think, is a better way to do it. So if we're looking at this rectangle up here, we have the base of 6 and the height of 3. So 6 times 3 is 18. We include the inches. And how many numbers did we multiply together? 2. So it's squared. All right, so let's look at this parallelogram. Wait, we have the height is 3 and the base is 6. Oh, it's the same thing. 18 inches squared. Okay, because the reason I like this base times height, and this is a good example to look at it from, is, well, what is the length of this parallelogram? Well, it's 6. What is the width? It's a little misleading. This edge right here is not how wide it is. It's this from here to here is how wide it is. So you have to, I really like this terminology instead, because a lot of students think, oh yeah, well the width is 3 when they have this, when it gives this diagonal piece, and it isn't. We have to have the height and we have to have the base. All right, let's take a look at number 3. Okay, we're going to go, it's division, so it's keep it, change it, flip it, or find the reciprocal. So we got 7/10, keep it, change it, flip it, and then we're going to multiply, or we can simplify right here, and we get 7/2, but we need to, that's an improper fraction, so we got to go 7 divided by 2, goes 3 times, 3.5. All right, there's your bell work. Let's move on. All right, guys, the notes that we did yesterday actually work for this assignment also. And the notes that we will do tomorrow will go with the lesson for tomorrow. So there are not really any notes for today. But we are going to go through this practice. There is a little bit of a review on it to kind of keep your mind thinking about things that we already have been talking about. So let's take a look at number 1. Again, we're revisiting how to write an expression, changing these words into numerical expressions. So 8 more than number G. Okay, well, you know what? I see a then. What does that then mean? What does then mean for us? Well, remember, we flip things. So it's G and it's more, so it's plus 8. Okay? A number K fewer than 24. Again, this has a then in it. So again, we have to flip it. 24. Fewer means subtract K. All right, moving on to number 3. 6 times a number Y. Well, there's a couple ways you could do this. 6 dot Y, 6Y, or 6 parentheses Y. All of those work. The quotient of a number n and 7. Okay, n quotient means divide, 7. The sum of 8 and a number E. Sum means plus, and it means there's no then, so it's just as written, 8 plus E. Number 6, twice a number n plus 6. Well, twice a number n would be 2 dot n plus 6, or 2n plus 6. That's the more preferred way because it's more simplified than the other one. Number 7, a number x decreased by 13. So x minus 13. Number 8, 7 less than 3 times a number m. Whew, that's a lot of stuff. So 7 less than 3 times a number m. So 3m minus 7. 15 more than the quotient of 24 and a number x. So we have 15 more than the quotient of 24 and x. So 24 divided by x. The sum of a number y and 30, all divided by 5. Okay, so y plus 30, all divided by 5. The product of 2 and the sum of a number x and 9. So we have 2 times x plus 9. All right, so now we're getting back into that distributive property that we've been talking about the last little while. And we are going to just go 8 times x, 8x, times 8 times 3 is 24, and we're done. So moving on, we have 13, which is 3 times c, 3c, plus 27. Okay, this is pretty basic, pretty easy until we get down here. So I am just gonna, what I would like you to do is I would like you to try, well, let's just do these. 5 times 9, 45. 5 times 6w, 30w. 8 times 4t is 32t. I don't like doing t's, but there you go. Minus 8 times 2t is 16t. So 16t. Now, this is where you need to listen. This is a 32t, and this is minus 16t. They are in the same family, so we can combine like terms here. So what is 32 minus 16? Well, it's 16t. That is my answer. So if it is in the same family, we have to look for combining. So don't forget that. Let's take a look at number 18. We have 6y. This is in a family with this guy, and this one isn't. So we can combine things here. So 6y minus 3y is 3y, and then we'd have plus 3. Okay, looking at number 19, we have things that are in the same family. We have the 7, and that's it. Then we have the 4b that's in its own, in this family with this one. And then we have this, that's kind of a triangle. So that triangle is by itself. So, okay, 4b, well, let's do it in alphabetical order. So the a's come first. So we have 6a, because it's by itself. Then we have b's. 4b minus 2b is 2b. And then we have plus 7. Not too bad if you just remember that we can combine things. All right, so looking at number 21, I want to look at this one really closely with you because it has distributive property mixed in with just regular stuff. And we haven't really looked at that very closely yet. So, order of operations is where I'm going to turn here. What do we do first in order of operations? Well, parentheses. Now, we need to ask ourselves, does this 3, is it part of the parentheses? Well, if there's no symbol in between a number on the outside of the parentheses, it belongs to the parentheses. So we need to treat it as such. And so we use distributive property. 3 times x is 3x. 3 times 5 is 15. And then we have that 4 on the outside being added to it. Now, do we have anything that is in the same family? That 4 and that 15 are in the same family. And then we have this 3x that's by itself. So we'll do we'll do most complex before we do least complex. So the 3x has a last name, so we're going to go first with that and go 3x. And then 4 plus 15 is 19. There's our answer. Okay, so not too bad. It's just putting a couple of skills that you've already learned together is what it really is. So again, let's do this one. We're going to start out with 8 times t is 8t. Then we have 8 times 5, which is 40. Then we have plus 15. Always start asking yourselves, can things be combined? And we know that 15 and 40 are in the same family. And then we have this 8t that's on its own. So we're going to do most complex. So 8t plus 55. Okay, moving on to number 24. Number 24, no distribution here. We're just going to go well, let's put our boxes around our families here. And then we have those that go together. So now 2w plus 5w is 7w. And then we have 3 minus 1, which is positive 2. There's our answer. Okay, number 25. Now, just because there's decimals, we don't have to, treat it differently. It's just the same. So we go 3.2d. And then we have to go 3.2 times 1.7. So I'm going to write it down right here and solve it. 1, 4, 21, 22, 0, 2, 3, 4, 4, 5. Move my decimal over 2 places. Plus 5 and 44 hundredths. Can I combine like terms? No, that is as far as I can go because we cannot combine something with a variable with something that does not have a variable. So we're done with that one. All right, fractions. Do we need, I skipped a whole bunch over here, but that's okay. Do we have to freak out because of the fractions? Nope. We know how to multiply fractions. So let's try this one out. 2/3 x is 2/3 x. 2/3 times 5/6. So I'm going to write it down here. Can I combine? Can I simplify? Yep. I get 5/9. So this is 5/9 plus 4x. Oh boy. Can I combine? Yes, we can combine the 4x, whoops, and the 2/3 x. And then this guy's all by himself. But this is kind of, you don't have to freak out about it, really, because it's a whole number with a fraction. Well, what do we call a whole number with a fraction? A mixed number. So all we're doing here is going 4 and 2/3 x minus 5/9, and we're done. Okay, I'm kind of glad I didn't do that last column. I would like you to pause the video and try 14, 17, 20, and 23 on your own. I'm going to do them. So after you get them done, hit play again and see if you get the same answer that I got. All right, so you should have got 16r plus 24. Can't combine, no like terms. 6t plus 6m. Again, no like terms. So that's all we can do there. Number 20, 9x plus 9y plus 45. Well, that's an x and that's a y. They can't go together. And then number 23, 4 times y is 4y. 4 times 11 is 44. And then we bring down the negative 10. Combine like terms, the 44 minus 10 is 34, and we still have that 4y, so it's 4y plus 34. All right, hopefully that helped you to kind of understand what we're doing today. Let's take a look at the assignment now. Okay, as I look at this assignment, it looks pretty similar to the practice. So I don't see anything in there that it looks too complex. I think you guys can handle doing this. Okay, so look at this. This describe and correct the error in writing the expression. Okay, look at this. This is what they got. See what, now I want you to do this one and see what you get. Did you get the same thing? Well, if you got the same thing, there's a problem because it's an error. So what did they do wrong? Tell me in words right here what they did wrong. On number 14 and number 15, I would like you to draw what it's saying and try it out. Guys, your assignment, I think you can handle it. So give it a shot and see how you feel about it. If you have problems, ask your teacher. Until next time, good luck.